Okay. So thank you for your time coming to today's my session. My name is Ryusuke Kajiyama. I'm MySQL sales consultant. I'm working at a company named Oracle Corporation, but I'm responsible for product named MySQL. Maybe for some of you, it sounds a bit weird because Oracle is database. MySQL is also database. But now Oracle Corporation is really serious about MySQL, which is open source database. Of course, we continue to do the business of Oracle database, but MySQL is becoming a big boom worldwide, and also it's become really important role in Oracle Corporation. So let me introduce what is MySQL, as well as how we can use it, or what is the technology inside of MySQL, and also what is the future of MySQL. So first, MySQL is sometimes referred as the Dolphin. Yes, the logo of MySQL is Dolphin from the beginning of the development. And also, MySQL was a small company before. MySQL was a Swedish company based in near Stockholm, the north of Stockholm. And it was tiny company who developed MySQL, but also doing the technical support from the beginning. And I'm one of the original members of MySQL organization. Then our company was purchased by a company named Sun Microsystems. It's already gone because Sun Microsystems was also purchased by Oracle Corporation. So MySQL members are now in Oracle Corporation. So let's discuss about MySQL, but Oracle Corporation is driving the innovation of MySQL. That's one of the key messages I have to mention about MySQL. If you're already familiar with MySQL, you don't have to worry about the future of MySQL, or you can expect bigger, bright future of MySQL under Oracle Corporation. So let's discuss why Oracle is positive about MySQL and also how MySQL is improved these days. Before jumping into the MySQL products, let me announce one new thing regarding to MySQL, which is a product named MySQL Cluster. MySQL usually referred for MySQL Server, which is open source database. MySQL Server is a typical RDBMS, relational database. However, the MySQL Cluster is a slightly different technology, which is based on MySQL Server, but which has completely different characteristics, which has completely different usage, as well as different interfaces. These days, in database or data management industries and so on, NoSQL or NoSQL is booming so fast. MySQL Cluster is originally developed as NoSQL, NoSQL, because originally it did not have any SQL interface. It only had an API, NoSQL API. Well, we developed this product around year 2003, close to 10 years ago. But we developed NoSQL. However, the MySQL cluster as NoSQL is not the same as NoSQL in the world today. Because API, NoSQL API of MySQL cluster was C++. If you are web application developers, C++ must be the worst language to use. If you love to develop some kind of the devices, yes, C++ is a good programming language, but everyone hates C++ who are working in web industry. So now we are modifying the API of MySQL cluster to fit with today's NoSQL requirements, which is introduced last month. So MySQL cluster was originally designed for the telecommunications infrastructure. Whenever you moved from one place to another place, your mobile phone companies, either China Unicom, China Telecom, China Mobile, whichever, must track you where you are to establish next connection. So whenever you move with your mobile phones, your location record will be updated. MySQL Cluster is designed for that kind of usage. So that's the first place for MySQL Cluster where a lot of write to transaction updates will happen. As well as it requires quick response. It says less than 3 milliseconds. It's semi-real time. Also, if these databases were broken, crashed, telecommunications company lose money. So MySQL Cluster is designed to achieve the requirements of these customers' usage. And now MySQL Cluster is used in more mission-critical environment. US Navy aircraft carrier, which is a huge ship carrying about 50 jet fighters, plus thousands of the people working on this ship. MySQL Cluster is used in the flight deck management, fuel management, and also maintenance record management. These are critical in this ship to maintain the maintenance of fuel of each jet fighters. Because there's only one place to land or come back to ship, only one place to depart, fly from this ship. So management of the flight deck is really critical component of this environment. But MySQL Cluster is used. Why? Because there's no single point of failure. There's no single point of failure in MySQL Cluster. So let's discuss about architecture of MySQL Cluster. So here on right-hand side, you see MySQL server. If you're using any SQL-based, SQL-based application, you can access to MySQL server as usual. However, these MySQL servers on the right-hand side, they don't have any application data. Your application data is managed by servers named data node. That's completely different from standard RDBMS. These data nodes are actually servers. That MySQL server, yes, that's running as a single server, but never store any of your application data. So data is distributed. Data is distributed among multiple data nodes. Data is managed by remote servers. So that's basic idea. First, data is managed by remote servers. That's a basic idea of MySQL Cluster, number one. Number two, data is always distributed and duplicated. So in this environment, we have data from number 1, 2, 3, 4. And data 1 and 3 is managed by node group number 1. Within node group number 1, data fragmentation F1, fragmentation number 3. So data number 1 and number 3 is always mirrored by these two servers. So if we change something on data node number 1, that's always reflected to the node number 2. Now we have the same set of data on two different servers. Data is now duplicated. We can have sets of these groups. In this diagram, we only have 4 data nodes. So now we have two node groups. Within single node group, again, they're mirroring each other. We can have multiple sets of node groups. We can add data nodes without stopping the whole cluster. So idea is similar to RAID 0+1 of disk array. Because if we were using RAID 0+1, which means striping and mirroring of data among disks, MySQL Cluster is doing this over network. So this is a completely different technology from existing RDBMS. Any kind of RDBMS cannot do something similar to this one. But another important thing on MySQL Cluster is, excuse me, I skipped too much. MySQL Cluster is SQL-based database. Because we have MySQL server on right-hand side, we can connect to the data through SQL statement. But as I mentioned, MySQL Cluster is originally designed or developed as a NoSQL, NoSQL data storage. Yes, we originally had a C++ as an interface. But C++ never fit with web applications. And MySQL usage, large portion of MySQL users, large part of MySQL users are doing web applications, operating websites. So now we added different APIs. Starting from Java, it was easy because just wrapping the C++ API was JNI, Java Native Interface. We also added an interface for the Apache HTTP server. The component is so-called ModNDB. ModNDB is a REST API for data nodes. Another component, and also newest one, and also we are expecting this will be big boom, is Memcached. Memcached is open source distributed cache, which is widely used by today's huge websites. Even in United States, even in Japan, even in China, if we see the huge websites, they're utilizing Memcached somewhat in their website. And in many cases, combined with MySQL. That's today's trend today's big trend in web. So Memcached is used for the cache, front-end cache of database usually. But in this case, Memcached will be used as the interface of data node which stores data of MySQL cluster. If you talk with Memcached, with the protocol of Memcached, our plugin, which is of course open source, we added a plugin into Memcached. That plugin translates Memcached protocol to internal API of MySQL cluster. So now MySQL cluster can talk through Memcached. The Memcached is key value data store. So key value data store is becoming a big boom right now, but there are many headaches to use today's open source key value data store, especially for the data management or data maintenance. Cassandra, MongoDB, whatever, today's NoSQL, the huge headache is how to have the consistent data in data repository. That's really painful. So that's why a number of customers are moving towards NoSQL and coming back to MySQL. The one of the huge case who stepped out, so moved away from MySQL to NoSQL, was US company named Twitter. They moved from MySQL to Cassandra, which is NoSQL implementation. But they suddenly came back to MySQL because they realized it's impossible to maintain data consistent. But a MySQL cluster can solve all those pain. Because data nodes of the MySQL cluster is always duplicating data. We manage data in transaction. Data node has an internal transaction. So now MySQL cluster is shared nothing, active database cluster, as well as transactional key value data store. So now MySQL cluster has two faces, as database, as NoSQL. So this is a new technology we announced last month, February 15th, we announced this product. There's a number of slides, but let me skip to MySQL server, which is a more standard, regular product, or maybe you are already using. So MySQL database, which originally developed in starting from 1993, 1994. Now it has more than 10 years, close to 20 years of history of development in MySQL. However, it's still open source and a young technology, so we are seeing more and more customers utilizing this product. And I'm really believing this is a great opportunity for all the people here because number of companies are utilizing MySQL these days, which means in the other world there will be lots of job opportunities as well, if you are familiar with MySQL very well. So today I would like to introduce the newest, today's major version MySQL Server 5.5. and also step into the architecture of MySQL. Maybe some of you are already familiar with, but let me discuss about architecture of MySQL server, and discuss about replication, which is widely used by web companies these days. And also talk about future version, which is MySQL 5.6. Hopefully we can release by the end of this year. Can be early next year. So first, MySQL 5.5 is today's major version of MySQL server. The MySQL version number is always some point some. So 5.5 is the major version. Next major version can be 5.6. So only 0.1 version up. But that's a major version for MySQL. So MySQL 5.5, the largest difference from previous versions, comparing with like MySQL version 5.1, largest difference is InnoDB became default. What is InnoDB? That's a storage engine of MySQL. Then what is the storage engine? So I have to explain those discussions, starting from what is storage engine of MySQL and what is InnoDB and what is the characteristics architecture of InnoDB in later slides. I'm preparing the slides. The MySQL 5.5, if you are using MySQL, which requires higher performance, please use 5.5, not 5.1 or older versions. Especially if you are running MySQL server on Windows, we do recommend to use MySQL 5.5 rather than older versions. Because there's a huge number. Okay, so 1500, 15 times, 15 times faster than older version. If you compare performance of MySQL 5.1 on Windows, 5.5 on Windows. So especially if you're running MySQL on Windows, we do recommend, of course, even Linux is faster, but that's a huge enhancement in 5.5. Semi-synchronous replication. I have to discuss about what is a replication first and discuss about what is a semi-synchronous. So let me explain that one in later slides with actual diagram what it is. Multi-CPU scalability. Today's hardware has number of CPU cores. Even our desktop PC or laptop today already having 2 CPU cores. Today's server starting point is 2 CPU cores or maybe starting from 4 CPU cores. And the total number of CPU cores is growing so fast. So we optimize MySQL server because previous version, blue line on the screen, MySQL 5.1 was too slow or cannot scale. On X, that's 4 CPU cores, 8 CPU cores, 12 CPU cores, and 16 CPU cores. So more and more CPU cores. We knew why, now we know why, but MySQL 5.1 is slowing down. 5.5, no problem, it's scaling. So if your environment has lots of CPU cores, MySQL 5.5 is the right choice. So let me come back to this slide. Whoop. Let's discuss about architecture of MySQL. What is a storage engine or InnoDB, whatever? So first, storage engine is the most important keyword in MySQL. Only MySQL has this feature named the storage engine. No other RDBMS, no other databases has a feature named the storage engine. That's MySQL's original feature. But let's discuss on this diagram. Big box is MySQL server. Your application is sitting on the top of the small blue box on the top of big box. Then from your application, when you're connecting to database server, if you're developing application with Java, you may use JDBC driver. If you're developing .NET application, we need an ADO.NET or something else, or maybe ODBC driver. If you're connecting to database through C or Perl or Ruby, PHP, Perl, whatever the languages are, there are not always client libraries, drivers, or module to connect to database. We have we develop a number of those interfaces for application. Now you could access to database. Here's a connection management of MySQL, but first, there will be important process, user authentication, whether this user is okay to connect to this MySQL or not, will be judged by authentication layer of MySQL. The one unique implementation of security management of MySQL is MySQL user account is always a combination of username and host name or IP address of clients. MySQL Server also can use password, of course, but user account is always a combination of username plus where you are accessing from. So user A connecting from localhost and also client user A connecting from other client will be recognized as two different user accounts by MySQL. That only happens in MySQL. So if you learn this from MySQL, if you move to Azure DBMS, you don't see this kind of the user management. But that's also unique to MySQL. Then, after you successfully came through the user authentication, you go through the SQL, you can use SQL statements. Your SQL statements will be understood by parser. Parser will convert SQL statement, which is a more human-readable script, convert into MySQL's internal API. Optimizer will optimize how to fetch, what is the fastest way to fetch record or changing record in data. Cache and buffer on right-hand side, which is a main memory area, caches part of data into main memory. Why do we need a cache in main memory? Why do we want to use cache or buffer in main memory? One of the reasons is disk is slow. Hard disk drive is still the first slowest component in today's PC or server. CPU became much faster than before. Memory is always fast, but disk is always slow. So even SSD or new technology like Fusion IO came in, still slower than main memory access speed or CPU clock speed. So we try to avoid disk IO. If we could avoid access to disk, we can avoid the place which is the slowest in the hardware, which means we can accelerate system performance. So that's why any kind of the database or even application servers or web servers try to cache data into main memory. Yes, we do have the same design here. However, connecting to database with driver or client library, user authentication, parser, optimizer, cache buffer, those are pretty much the same as any other RDBMS. Of course, detailed implementation is completely different, database by database. But steps from application, driver, authentication, parser, optimizer, cache buffer, pretty much the same with any other RDBMS. However, the most important technical component of MySQL is so-called storage engine. So what is a storage engine? It has 5 functions. The first one is really easy to understand because name sets how to store data. Yes, name sets storage engine. Storage means how to store data. Where to store, how to store, what is the layout of data depends on storage engine or implemented by storage engines. Most of storage engines in MySQL store data into disk. However, If you're already using MySQL, I hope you're already using this storage engine. Storage engine named memory storage engine. Memory storage engine. Where will this engine store data? Into main memory. In the world, we can instantly create in-memory database within MySQL server. Memory storage engine, of course, which is available in open source, free community version of MySQL. We can instantly create an in-memory database. So where to store data depends on storage engines. Number two, how to use main memory. How to cache data into main memory or how to utilize main memory. It depends on storage engines. Number three, transactions. Transaction of database is usually mandatory to transaction is usually mandatory to database. But in MySQL, transaction implementation is controlled by storage engine. Some storage engines does not support transactions. It's also true, if you're coming from other RDBMS to MySQL, some people feel really uncomfortable. Why database does not support transaction? Well, that's our implementation. So all the storage engine named MyISAM. These days we don't recommend to use MyISAM anymore because it's too old, which does not support transaction. InnoDB storage engine, today's default storage engine, which do support transactions. So number four is concurrent access control, or so-called lock of data. Because if someone is changing data, that data should not be changed by someone else. So we have to lock that record and change it and unlock and let others to change. The lock implementation is also depends on storage engines. InnoDB storage engine lock per record, so-called row level lock. Each records will be locked individually. However, MyISAM, old storage engine, locks whole table. So if one client is changing one record in 1 million rows table, 1 million rows record table, only one record will be changed. If you are using MyISAM storage engine, whole table will be locked, which means other people never be able to change record until that first person unlocks the table. But if you were using InnoDB, it's per record. So if I was only changing one record, okay, that record, yes, I'm locking right now. Other records, you can change it, which shows better concurrency. Of course, InnoDB. So InnoDB shows much better concurrency than MyISAM. That's also another reason we don't recommend MyISAM anymore. It's too old. So and then so as I mentioned, how to store data, how to use main memory, transaction, and concurrency control. The last one is features. Features, sometimes some unique feature is only available in some storage engine. Ones like InnoDB. Of course, it supports transaction. Foreign key is only supported by storage engine named InnoDB. Foreign key is also one of the basic features of database usually. Most of today's modern RDBMS, any kind, PostgreSQL, MSSQL, IBM DB2, Sybase, whatever, most of them are supporting foreign keys. In MySQL, storage engine like MyISAM, memory storage engine, or even InnoDB cluster storage engine, which is used by MySQL Cluster, which does not support foreign keys. So those function depends on storage engines. So MySQL has a number of storage engines. By default, I believe in today's implementation, we have 1, 2, 3, 1, 2, 3, 5, 6, 7. We usually, if you download MySQL server as of today, I believe you will not see this one, cluster storage engine, nor custom storage engine. But all other engines, you can use it. There are a number of unique ones. By default, MySQL 5.5 InnoDB will be used. MyISAM, again, was designed for the file replacement, flat file based on data management. If you're managing data by text files, maybe good idea to switch to MyISAM. Memory storage engine, we can instantly create in-memory database. Archive storage engine, I like this one because we can add a new record and read it, but no one can change it. If we create a table with archive storage engine, we can insert and select record. No one can update nor delete. So in that table, we are sure no one has changed. Only insert happened. It's really useful if we need to track some historical events like logging or auditing. So archive storage is designed for that kind of purpose. Of course, we can truncate the whole table, or if we have multiple partitions, we can drop part of the data with dropping partition from the table. So archive storage engine is pretty useful. By the way, by default, it's compressed the data. What else? CSV storage engine. CSV storage engine, data file is CSV. So if you have an existing CSV file, you can easily load into MySQL and select data by select statement. However, huge limitation of this CSV storage engine, which never supports indexes. No index. So if data was huge, it will be extremely slow. But if your data was not huge, it can be useful because data file format is still CSV, comma separated file, which is text file. You can open with text editor. If you love Excel, yeah, you can open with Excel. But still, you can use SQL statement against the same data. So that's a CSV storage engine. Merge storage is a bit older technology, which realized the patterning in MySQL. So there are a number of storage engines. But if you are interested in more from the deep technical side, if you're interested in to develop your own storage engine, there is a template of the storage engine named the custom storage engine, and it's only in the source code distribution of MySQL. But you can generate your own storage engine. Then a couple of years ago, I believe it's already 6 years ago, one of the developer in our team tried to generate new storage engine of MySQL named PostgreSQL. Unfortunately, it didn't work well, but the idea is your application is talking to MySQL, but this storage engine convert API from MySQL's internal API to other RDBMS API. The one successful case for this unique combination of databases was IBM DB2 storage engine for MySQL. It's a very confusing name. That's a storage engine of MySQL, but your application is talking with MySQL. DB2 storage engine convert MySQL internal API to IBM DB2 API. Data is written into data file of IBM DB2. Or if you're familiar with cloud storage from Amazon. Amazon has a storage named Amazon S3. Another unique implementation of storage engine is so-called Amazon S3 storage engine. If you insert a new record into MySQL server, Amazon S3 storage engine is converting MySQL internal API to put method of HTTP and write it into Amazon S3 storage engine. Select statement becoming the get command of HTTP and fetching record from Amazon S3. So there are a number of usage you can think about because insert statement and select statement or update delete, it's not easily used by application. It's not really complex programming. But if we found completely new API of new technology, we can wrap those technology with SQL statement. So that's also completely different potential of storage engine of MySQL. Then how to use this one? I explained the storage engine, what it is, and this is examples, how to use it. It's really easy. So if you install MySQL Server, just type show engines command. Show engines and \G. Do you familiar with this one? Usually we type semicolon at the end of the SQL statement. If you change this one to \G, let me check keyboard here. Okay, not the yen sign here. Right. Whoop. \G just change the output. So result is the same. How it looks is just different. So first one is show engines command. If we type show engines command, it will return the result of which engines we can use right now. It pretty much depends on the major version of MySQL Server. It's a slightly different version by versions. So this is just an example output. So here's engines we can use. Maybe you will see some engines you've never known before. Please play with it. Some of them are really useful, especially memory storage engine. I do recommend to play with. How to use engines? We can decide to use engine when we create a new table. Create a table name, column definitions. As a table option, engine equals engine name. By the way, by default, MySQL has a default storage engine. We can change default storage engine with this parameter, or you can check, select at storage underscore engine. You can see what is the default storage engine right now. Default engine means creating a table without engine equals something, default engine will be used. If you found, okay, I made this storage engine table as an InnoDB storage engine, I prefer to switch to memory storage engine. It's really easy. Auto table name, engine equals engine's name. It's a really simple command. But in production side, or if you have big data, please be careful to use this command. Because this command internally creating the empty table with the same table structure and loading data from old one to new one. So if you have a large amount of data, this command may take time. So please test with smaller size of data, how long it's going to take. I estimate that when data became bigger, and if it's acceptable, just go for that one. So which table is using which engine? Just type show create table command. We can see the table create, or show table status command will tell you the engine details and so on. And the information schema, which is the metadata of MySQL. It gives you the list of the table information. So there are a number of engines in MySQL, but let me explain about architecture of InnoDB storage engine. So InnoDB storage engine is a default storage engine of MySQL Server, which uses transaction, which you can use with, excuse me, you can use this, you can use transaction, excuse me. It supports commit, save point, rollback, and ACID compliant. What is ACID compliant? It can be a good question for the exam for the computer science people, I guess. A stands for the atomic, C for the consistent, I for independent or isolated, and D is durable. That's a basic requirements of transaction. Yes, InnoDB do comply with full ACID of transaction. It also has a auto recovery on the crash, MVCC, multi-version concurrency control. MVCC is used in concurrency management. It's not a special idea anymore today. If we want to implement some concurrency control, MVCC is kind of today's standard. MVCC is steps of the MVCC is like this. The first transaction is trying to change some record on disk. It will generate a copy of data into main memory. It's a one version of data in main memory, and the first transaction will change data on that against that copy. If another connection try to change the same record, that connection also generate the copy of original data into main memory. So there will be another version of data. So first version 1 will be updated by first connection. Version 2 of data will be updated by another connection. Depends on the timing of a commit, which data will be stored, or how to isolate it. So record, it depends on transaction level, but that's the basic idea of multi-version concurrency control, having multiple version, multiple copy of original record. So InnoDB is using MVCC to control multiple access. Then this diagram has too many characters. So let's discuss about transaction management of InnoDB. Then this one is talking about transaction management of InnoDB. However, the basic idea of transaction management of InnoDB is never far from the basic transaction management algorithm of database. So again, detail implementation can be different database by database, but basic idea is somewhat similar to InnoDB's transaction management. So if you're familiar with transaction management basics of other databases, that's very similar to what we are doing here in InnoDB. So let's see transaction management of InnoDB. So there's 4 areas. Left-hand side is main memory. Right-hand side is disk of, left-hand side is memory. Right-hand side is disk. And upper layer is log file, it says. Log file is logging your transaction information. In the other word, transaction information, your update statement, insert statement, delete statement, and so on. DML. Table space, it says table space. That's the actual data. So let's see the name of area in InnoDB. In InnoDB, we are using main memory area, which stores transaction, ongoing transaction, which is called as a log buffer. On disk, InnoDB can have multiple log file. For the data, if we are changing some record, the copy of data on disk will be copied into main memory area named buffer pool. Multiple versions will be written into buffer pool. Finally, InnoDB has a data file where your actual data exists. In MySQL, we don't call log file of InnoDB as a redo log, but logically, and also in other DBs, it's so-called redo log. There's another log file named undo log. So let's see one by one. So when we are changing some record, first, your ongoing transaction will be written into main memory area, so-called log buffer. In the same time, now I am sending updates. I want to change some record written on the disk. InnoDB will fetches that record into main memory area named buffer pool. Then my update statement will be executed against data in this area, memory and data. So this memory area data will be updated. If I'm updating record again and again for a long time, those update statements will be written into this memory area, but this memory area can be full. In that case, my ongoing transaction, which is not committed yet, will be written into log file, so-called undo log. Undo log stores, which is still ongoing transaction, so which is not committed yet, which can be undo. We may cancel. So that will be recorded. On commit, so we decided, okay, this change, we want to persistent this change. On commit, transaction information, so my updates, will be written into disk. The file named redo log. In InnoDB, there's no special name. We just call InnoDB log. But in any other DBMS, it's so-called redo log. At the moment of commit, this is all thing will happen. This is everything. Eventually or later on, data changed in main memory will be written into disk. It says checkpoint. It can be the certain checkpoint, certain points, or if this area was filled with dirty record, which is not flashed into disk, there's a percentage we can control. If some dirty data with integer which is not written into disk, filling the buffer area certain percent, this checkpoint types of the flash into disk will happen. So the key point is this moment. So you decided to commit, and MySQL server MySQL server wrote main memory data into disk only for transaction information. If before this operation happens, if MySQL server was killed, what's going to happen? Transaction information is already written into disk, which means your transaction successful. However, data is not written into disk yet. Then server was killed. If we could restart server and disk was not damaged at all, what we will see is, okay, log file says your transaction is successful. It was okay. Your data is still old. So that's a big problem. Because transaction log file says, okay, transaction completed, data still says your transaction never happened. So that's so-called roll forward recovery or crash recovery in most of the database. In MySQL, we call crash recovery. On boot of MySQL server compares with information here and information here. If MySQL server found, wait a minute, redo log file contains this transaction, but if data is still old, it will automatically apply transaction information into data. So that's a crash recovery of MySQL, only available in InnoDB. But again, the basic idea of this one. So explain from transaction management, on commit, only redo log file is written, data will be synchronized later on, or in case of crash, there can be the crash recovery. That's a basic idea like Oracle database still has. So pretty much similar with Oracle and InnoDB. So this is a brief overview of the transaction management architecture of InnoDB. Again, this never be special thing. It's a standard, written into the textbook of transaction management of database. So InnoDB is implementing that logic into actual source code. So this is an overview of the InnoDB, and what else I have to explain? Yes. Yeah, sure. I got it. Yeah, let's take 5 minutes. So let's continue about regarding to InnoDB, because again, which is default today, which is widely used, like more than 90% of people running application with InnoDB anyways. So when we think about performance tuning of InnoDB, especially MySQL Server, if we are using InnoDB most of the case, the most important component of this environment is this one. Having large buffer pool of InnoDB is one of the huge key component of the MySQL Server parameter tuning. So this area can be somewhat important. Yes, if you are running long transaction or big transaction, which means you are updating a number of you're changing record number of times in single transaction from begin to commit, or your single update statements are giving number of record in single updates. This area must be big, or another area in MySQL Server, so main memory area, so-called sort buffer size. It can be important if you are doing huge order by or group by. But if you assign a certain memory area for those parameters, we recommend utilize like 80% of available main memory to this area. It's really easiest way to tune MySQL Server. That's a basic. So because this area fetches large record, try to put it into main memory. If you have a huge area, yes, we can load the data into main memory as much as possible. It will accelerate the performance of insert, select, update, delete, all operations. So that's the basics of the tuning. I don't recommend explain too much about details, but if you're running MySQL, the two commands you have to remember. Too big to fit. So I'm currently accessing to MySQL Server here. Two basic command for performance tuning. What you have to know is show global status. You may already know. This gives you the status of MySQL Server. There are over 300 parameters exist. Some of them are really easy to understand. Uptime. Yes, how long this MySQL Server is running in seconds. I just booted this MySQL. Or a bit more internal thing. So I talked about buffer pool of InnoDB is important. We can check the usage of buffer pool with this command. For example, what is the size of total size of buffer pool? It says the pages. Yes, it has 8,000 pages. Per page is 16 kilobyte. So 8,000 times 16 kilobyte. That's the current size of buffer pool. How much of this main memory area is free right now? 7,752 blocks, actually pages. So now we can estimate the size of data, or which is actually dirty, which is not flushed yet into disk. We can see those size from there. Another important thing is this, buffer pool reads. How much of access or reading record, how much of data were read from this area? Or buffer pool read request. How many times MySQL Server try to read the data from here? We can compare this number with some others, and it can be important for tuning. Another points are here. Things starting from com is all of internal operation of MySQL. Com select, that can be easiest one to understand. Yes, com select. In my environment, there are two select command I've typed already. If others executed the select command, you can see the numbers. Then sometimes we compare how many times people try to search record, and also, for example, temp table disk. Where is it? Forgot. Select range check, this one, these ones. If I cannot find the things right away, what I have to type is select show global status like. I hope this is the right one. Right, this is what I wanted. Okay, so show global status like TMP. We can filter the outputs of the show global status command. Now I wanted to check is how many temporary tables are generated, and the worst one can be this one: temp table, temp disk tables. To do some select or whatever operation, if MySQL needed to do this, means MySQL generated new table in disk only for that SQL statement and removed after that query. This operation will be really slow. If this value was increasing so fast, we have to think about increase the size of main memory area for temporary table, or avoid creating a temporary table in your application. Why I'm saying this is actually this is one of the common problem we encounter in MySQL business or day-to-day work. MySQL is used in phishing project of the China Mobile. I'm not sure how many people are using phishing from China Mobile. You know that one, right? Yeah. So phishing is actually running on MySQL. And actually, it's years back, early days of the migration from Microsoft SQL Server to MySQL. I was involved into that project. They have a huge performance issue. It was slow, extremely slow. I still remember how slow it is. It was still prototype version. Someone try to send a message. It takes like forever to send. Largely because, of course, size of the InnoDB buffer pool was not optimized at all, as well as they never check this value is jumping so fast. Because of the application issues, that was a completely problem of the application developers. But they generate a number of temporary table into disk, which is a really slow operation. So what I did recommend was please increase the size of some parameters. Show global variables, global. Max temp tables, no, temp table size, this parameter. So temp table size limits the size of the temporary table created in main memory. If data size of a temporary table was bigger than this one, it will go to disk, which will be extremely slow. Usually this number is good enough because this is 16 megabyte. Usually it's good enough. But in that certain project, it must be bigger. Okay, we generated this parameter bigger, utilizing more and more main memory. So that's one concrete case through my experience for the parameter tuning. But again, two commands. Show global status. It's really important to remember, especially before benchmark and after benchmark, or running your single SQL statement and after single SQL statement. You can know what's going on in this operation. Is it one SQL statement or benchmark? But you can see, okay, so how many commands are used in MySQL through common commands. And also, there's a parameter, excuse me, I forgot. What is the temp command? Excuse me, where is it? There we go. Created temp. Okay. So must be OPQR. Okay, here is the information regarding to the temporary tables. It will be listed, not only select number of select statement or number of commands. And once you look into more detailed parameters, these parameters, InnoDB buffer pool, that will help to tune the size of main memory area. What else? What else I have to mention is Oh, there you go. Here's another important one. Sort merge passes. If you are doing huge order by, okay, so if you're doing sort of data, huge data, if this number sort merge passes, right now it's 0, it's good. If this number is growing so fast, MySQL server is sorting data sorting data on disk rather than sorting data in main memory, which is faster. Of course, main memory is much faster. So if this number is jumping so fast, you are doing too big sort. Maybe you can filter more data before doing order by, adding some condition into where. But if your application must do huge sort, what we can change in parameter is sort buffer size. This parameter, sort buffer size, by default, it's only 2 megabytes. So if your application is doing huge sorts, increase this parameter to fit all data into your main memory. But please don't make this parameter too big. This value is multiplied by number of your connections. So if your MySQL server has 100 connection, size of data for sort area will be 200 megabytes. If you have 1,000 connections, it will be 2 gigabytes. So please be careful to enlarge this parameter. But the good news is, we can change this parameter dynamically. Dynamically, on demand, or when you need. So right now, in my environment, sort buffer size says 2 megabytes. But set sort buffer size. Whoop. 100 megabytes. So 1, 2, 3, 1, 2, 3. Roughly 100 megabytes. I need to have the huge sort buffer area only for me. Okay, set sort buffer size and show my connection. Local variables regarding to sort. Now it became from 2 megabytes to 100 megabytes. So other connections, they use 2 megabytes. So 100 connection, still not huge. My connection, 100 megabytes. Good news. So if you especially this happened in the real world actually. Most of our web application no need to do the big sorts. But like batch operation, once a day, once a week, changing some information or generating reports, this technique works very well. So this is a basic idea how to look into the parameter of what is the status of MySQL and how to tune the data. This set command is also really useful in the real world. Okay, so before talking about roadmap of MySQL, let's discuss about this. Replication. What is a replication? What is a replication in general, not in MySQL? Replication is replicating data from somewhere to somewhere else. Replicate means make a copy of data. So replication in MySQL is the same idea. Make copy of original data on other servers. That's a replication. Then by default, MySQL replication is so-called asynchronous replication, but this technique is widely used by number of websites. Even in China, QQ, Taobao, and most of Weibo is utilizing replication. Why we want to have replication? Why we need to have replication in web application or consumer-facing web? Because with replication, we can distribute workload of reading data. So let's see why we can do it. On commit of your transaction, MySQL server try to change data and a file named binlog, binary log, in one operation. In MySQL asynchronous replication, application will get response of commit after data and log was changed. Then this replication operation copies content of binlog. Content of binlog will be copied into slave server. What is a binlog? Binlog stores all your transaction. What is transaction in database? That's DML. Update, insert, delete will be written into this log file. So those statements will be copied to slave server by replication. But still, data of slave is still old one. The slave server, which received those information from master server, must change data by itself. So this is a brief overview of flow of MySQL replication. Then why MySQL replication works very well with web? Because number of access come to master which change data on master server. We can have multiple slave servers. We can have a copy of original servers. Then number of web access can access one of slave servers. But why again web? If you are doing some web surfing, what you are doing is reading data most of the case, most of your time. Or maybe you are a huge web user and typing so many commands, but maybe most of the people are just reading your commands. So web is always huge amount of read of that's the type of application, type of access. So let's have a number of slave servers for read operations. We can distribute the workload of reads among slave servers. It fits really well with web. That's why MySQL is widely used in web. Now, of course, there are a number of reasons, but replication is a huge reason for the huge reason of MySQL in web. Also, if you are using, if you are planning to use, or if you're already using MySQL, understanding replication, utilizing MySQL replication will change the application architecture, accelerate the performance of web applications. It has a huge benefit. So by default, MySQL replication is so-called asynchronous. Then from MySQL 5.5, we introduced semi-synchronous replication, which is designed for higher availability or better durability of your transaction. So let's see what's the difference. So on commit of transaction, your data and binary of master will be changed. These steps are same with asynchronous. The difference is, before reply back to application, master server pushes transaction information to slave server, right into log file of slave server, then slave reply back to master, okay, master, I received the transaction. Finally, application get the response of commit. This one helps better durability of your transaction. Why? Let's see the difference. But before seeing the difference, we have to remember the ACID, ACID of transaction again. Especially, what is D? Durability. Durability or durable means if you receive the reply of a commit, if your transaction was successful, your transaction must survive any kind of crash. Your transaction must survive any kind of crash. Okay, let's see things in this diagram. When is the timing we can say our transaction is successful? This timing. Because you received the reply of a commit, which means commit successful, yes, transaction successful. If application received the reply of a commit and with some reason this master server was killed, what will happen to your transaction? Your succeeded transaction, what's going to happen? No problem. Your transaction is written into this log file, but it's already copied to slave server. So in case of failure of master, transaction already copied to another server, minimum one server, transaction can survive the crash. However, how about this one? When is the timing we can say transaction successful? This timing, okay? So from point of view application, set a commit, receive the response of a commit, transaction successful. If master server was killed right after transaction was succeeded, what will happen to your transaction? If this server was completely killed, if data center was completely gone, your transaction is also going away. Is this durable? No, this is not durable transaction management or not durable transaction. So asynchronous replication. This is not the problem of the MySQL. Okay, this is not the problem of MySQL only. Any kind of asynchronous replication, whether it is an open source implementation or even expensive option of Oracle database, if it says asynchronous replication, this risk always exists. In case of failure of master server, depends on timing, but you may lose the final transaction. That's a risk of any kind of asynchronous transaction. But why this one is widely used and a number of people love go with asynchronous replication? Because this one has a much lower overhead. All applications have to wait is master. How about semi-synchronous replication? You have to wait master and one network hop to slave. Slave have to write log file into disk. Another network hop coming back to master. If we are doing this replication within same data center, same network, at the same place, it won't be a big problem. But today's MySQL replication is widely used in connecting two different physical locations. Maybe in your environment, connecting campus from here to another campus. That's widely used with MySQL. For example, like running student management system with MySQL at one campus. In case of trouble of the one network or power failure of this place, we may have to continue all student management system. So we can replicate data from this campus to another server existing in another campus, connecting with replication. That's widely used, or many companies are doing this these days. However, unfortunately, semi-synchronous replication, if we do this between different campus or over big network, latency, response time will be really long. So many people just go with asynchronous replication because applications do not have to wait for network, or network latency never affects application performance. So that's a benefit. Both technology has a benefit. Both technology has advantages and disadvantages. So it depends on on the requirements. You can choose either one of these. And the good news is we can mix asynchronous replication and semi-synchronous replication, which means if we have three servers, one will be master server, one of slave server which received transaction from master will be asynchronous replication slave. That's maybe for the performance or maybe for the so-called disaster recovery, putting one slave server to other campus. Another server for the durability of transaction using semi-synchronous replication. So depends on the requirements. You can choose options of replication. So this semi-synchronous replication, again, it's available in MySQL 5.5. Today's version, if you are using MySQL 5.5 already, yes, it's already in there. So let me conclude the session with future of MySQL. MySQL 5.5 is today's major version. 5.6 will be the tomorrow's version of MySQL server. Again, we are planning to release this one hopefully by the end of this year, can be early next year. There are 5 major enhancements. Optimizer, which optimizing all access to the record. We are rewriting optimizer of the MySQL. Pretty much everything we are changing. Performance schema. If you need to do the detailed performance tuning of every single SQL statement, this schema, so this is a metadata repository, will help you because it will store the detailed steps of the queries. What kind of operation is executed right now in this phase? Internally, MySQL server need to open data file, scan some information first, fetching some record, and sorting data in main memory, and send to application. There is a couple steps. There's still abstract layer. There's more detailed information will be written into performance schema. InnoDB, storage engine, we are improving more and more. Most of them are pretty much minor enhancements, but like SSD optimization, more multi-CPU core optimization is part of the enhancements. Replication, we are adding more functions into replication, so-called global transaction ID, which helps to track which slave server has the newest information with a single command. That's is already implemented in the beta version. Time-delayed replication, that can be also interesting for some application users. Because time-delayed replication means if I change the record right now, and 5 minutes later, 10 minutes later, we can decide, okay, this slave is always having a snapshot of 5 minutes ago, 10 minutes ago, day ago, 1 day ago, a week ago. Depends on configuration, we can control delay, intentional delay between master and slave. Finally, we are saying this one again, not only SQL, so-called NoSQL, NoSQL. NoSQL is also coming to MySQL server. It's a big trend right now, so okay, we gotta do it. Let's look into the details. First, optimizer. There are a number of enhancements. By the way, this slide is already public information. You can download. I'll send you a newest one so you can distribute to everyone. But there are a number of enhancements exist. Like if you're selecting some record with limits, the current limitation of the limits is even if we are we are fetching only 10 rows. Okay, we are fetching 10 records from 1 million row table. Unfortunately, today's MySQL server need to fetch 1 million rows and filter. But new optimizer will be much smarter. Just fetching 10 records, done. Index condition push down. It's a how to searching index, and also how to join the tables. Without index condition push down, MySQL server need to fetch some record from storage engine, bring back into optimizer layer, fetching another table information back to optimizer layer. So between optimizer and storage engine, there are a number of internal interaction happens. With new implementation, index condition push down. Name says push down. Push everything down into storage engine. So all join operation using index will happen within storage engine that accelerated performance with huge jump of performance. So this number is just one of the examples. Batch key access. Batch key access and multi-range read it should not happen, actually. It should not happen. This situation or this enhancement happens in not optimized SQL statement. Not optimized means joining multiple tables, okay, to join of multiple table, column to join. So where table A is column 1, table B is column C, if those columns did not have indexes, so usually those columns should have index. But unfortunately, with some reason, if those columns did not have indexes, the main memory area where is it? Oh, here you go. Main memory area, so-called join buffer, will be used. This area, switching a record of two tables or multiple tables, and comparing the values in this main memory area. But sometimes, even if we had a huge main memory area, performance is still extremely slow. So we change how to fetching record from disk, push into this buffer. Now it has much higher performance than before. Please be careful. This value is not 1, 2, 3, 4. This is a 5, 50, and 500. So it's a huge performance enhancement. But again, this optimization is designed for the not good queries. Performance schema, I already briefly introduced. We can see the details of the MySQL server's internal statistics. So if you need a more detailed performance tuning of a SQL statement, this is the right place to visit. InnoDB, there are a number of minor enhancements. None of these are huge jump. And I also explained the time delayed replication. Where is it? Is it in here? Yeah, here we go. And much safer. Each servers will be more solid in the replication environment. Additional updates. IPv6, yes, finally it's coming to MySQL. And also timestamp, date time. Now we can use milliseconds and so on. So those are minor enhancements of the MySQL. We already released DMR, MySQL 5.6.4 DMR. DMR stands for Development Milestone Release. I don't know why we decided. I don't know why we are using this funny name. This one is just for the beta version, usually we call. So if you're interested in the future of MySQL, yes, you can download from dev.mysql.com/downloads. You can download MySQL 5.6. Then I have not explained about NoSQL of MySQL. Here's one. You can download this version only. This implementation only. You can download from this website, labs.mysql.com. This is a separate website from regular MySQL, because this is name says it's experimental feature. But MySQL is SQL-based, SQL-based database, as we knew. Sending a SQL statement, MySQL Summer understood, and InnoDB storage engine stores data or sending data back to application. We integrated MySQL Server with Memcached. So again, MySQL Cluster had a Memcached. MySQL Server has a Memcached. So if you're studying more and more about MySQL, knowing about Memcached is also really key in the future of MySQL. But we integrated Memcached push into MySQL Server. Now, if your application is talking with MySQL Server in Memcached protocol, so it looks same MySQL Server, but has a different port number than 3306. It opens connection from Memcached client. Now we can access to same data through different API. So if your application fits well with key value operation, you can go through Memcached. If you need a complex operations, you have to go through MySQL Server. So MySQL Server is also implementing NoSQL interface. Future development, we have not decided pushing these ones into MySQL 5.6 or not, but optimizing performance for the SSD and more multi-CPU cores. Cloud, SaaS, hosting, database as a service related features, the number of things requested like multi-tenancy, having auto-threading, and also so-called elastic, more scalable or more flexible resource management. That's also we are planning to implement into MySQL. High availability, there are more and more features we are adding right now. So regarding to the future development direction of MySQL is implement everything, okay? Implement everything available in MyISAM into InnoDB. So future version of MySQL, we don't have to use MyISAM anymore because MyISAM source code is so old and so dirty source code to maintain. So we are trying to remove MyISAM from the core source code of MySQL. That's things we are working on. And you may have many rumors around MySQL, like MySQL lost some key engineers and so on. That's not really true. Actually, core engineers of MySQL still together with us. People who left is more like old guys, original, developers. But unfortunately, those idea was a bit out of dated anymore. They should do completely different new. But InnoDB team is a new innovation coming into MySQL, and we are still enhancing product as it is. And also, you may forget about, but MySQL Cluster also exists. So it depends on applications, the characteristics is a MySQL server or MySQL Cluster. That's a place products you can use in web application, telco applications, and we are now moving more into mission critical environment. So this slide has a commercial versions as well. Just let me quickly discuss about not product, the business model of MySQL. It can be useful. It can be useful for your idea of your future business as well, because MySQL is free. As you know, MySQL is open source. You can download it for free. You can use it for free. But we are doing business. How we can do business is putting additional values around free product. Technical support is one reason for customer to pay, but tools, backup tools, management tools, we are distributing product for free, so we try to find more users. And if some customers' business became big, we try to do business with those customers. But we also love to see customer is growing so fast together with our product. So that's a basic idea of how we are succeeding business together with free product MySQL, and also helping customers' business with free product. All right, so that's pretty much everything in my presentation. I'm pretty much open to answer any kind of questions. And also, you can open the question. Yes.
How much data can we store in the table? How much data? The maximum record.
Maximum size of data. Maximum size of data. Right? Yeah. So in InnoDB, maximum size is a 64 terabyte. 60 TB, 64 terabyte. But it's not true maximum, because 64 terabyte is a maximum size of partition. So if your table has multiple partitioning, maybe 10 partitions, each partition, maximum size of each partition is 64 terabytes. So total size is, can be 640 terabytes with 10 partitions was 64 terabytes of data.
If we do it to that extreme limit, the performance will be very slow.
Exporting data, what is the question?
If the data in the table is very big, let's say 1 TB, 1 terabyte, the performance of the table will be very slow.
Technically no, but realistically yes. Why it can be slow is the size of main memory is limited. Because if data is tiny, okay, if data is the actual data size is smaller than size of main memory, all data can be stored into main memory. And if data is much bigger than size of main memory, only tiny portion of data can be stored, cached into main memory. So that's why systems tend to be slow if data is huge. So if we are storing, terabytes of data, we need to have minimum, tens, hopefully hundreds of gigabytes of main memory or more. So that's the reason, how much can realistically manage data is depends on main memory. But some customers are already running MySQL server. One server was 10 terabytes of data. Not only 10 terabytes total size, all tables, but that's pretty much a real number these days.
Okay, then that might be the end of the speech.
Sure.
Thank you very much.
Thank you very much. Thank you for your time.
It's all already time out. Okay.
No, it's 5:45.
Yeah.
Yeah, so